Hello and welcome to Theology Unleashed. I'm Arjuna and this is the channel where Eastern theology meets Western skepticism. Today we're going to be discussing the demarcation problem, which is how do you categorize something as science or pseudoscience? And to discuss this topic, we've got Seth Hart, and we'll be reacting to a few videos from some YouTubers and scientists and atheist activists. So Seth, could you start by telling us a bit about yourself and as it relates to your academic work in the subject? And thanks for coming on.
Yeah, appreciate you having me. So my academic work, I'm a PhD student doing science and theology at the University of Durham. And my interest in the demarcation problem emerged in my master's degree at Oxford. My supervisor, Alistair McGrath, who for people in apologetics, Christian apologetics, he should be familiar. He really works a lot within this sort of area and really started to push me to come to some sort of understanding of what categorizes science, what categorizes theology, because before you can even begin to ask the questions of how do these two fields relate, and what is philosophy as well. So the sort of Venn diagram where all three merge together. And that was sort of my introduction to the field, and it felt like it was sort of a time bomb that he set, because over the past few years of studying it for my doctoral work, it's become more and more difficult to try and place what makes science truly science and what makes pseudoscience a pseudoscience. And luckily, I found out that there is an entire problem that you call the demarcation problem that speaks to the difficulty philosophers have had in that.
Right, so shall we go straight into the clips, or do you want to say anything else about the subject? Yeah. All right, so we're going to start by I'll just cut to the thing. I haven't actually what's her name? Sabine Hossenfelder, or what?
Sabine, I think, yeah.
So
I
just need to.
I won't attempt the last name.
That's right. This one over here.
She's a very popular YouTube video on this.
There we go.
I'll go ahead and introduce it. And this one, I think, has over 130,000 views.
Yeah, she's a physicist of some variety, and she's quite a big YouTuber. She makes good, clear videos on subjects, but this particular one simplifies the subject too much. So we'll play it, and you can just tell me when you want to pause and comment.
Sounds good.
I think the task of science is to explain observations. So if you want to know whether something is science, you need A, observations, and B, you need to know what it means to explain something in scientific terms. What scientists mean by explanation is that they have a model which is a simplified description of the real world, and this model allows them to make statements about observations that agree with measurements. And here's the important bit: the model is simpler than just a collection of all available data. Usually,
okay, we can pause it here. Okay, so she shifts around a bit as the video goes on. I think we're a little bit ways into the video, right? We skipped a little bit.
This is in order, so I just cut the beginning off where she sort of says a bit about the subject and talks about conspiracy theories.
Gotcha. Yeah, just to give a little background to that section. At the very beginning, she says there's been a lot of questions regarding what makes science science, and she flashes on the screen two books, ones that for anyone who's interested are just must-reads. It's Karl Popper and Imre Lakatos. Those are two authors. If you're interested in this topic, those would be two, along with Feyerabend and Thomas Kuhn, those would probably be the biggest thinkers on the demarcation problem. Now, I got excited when Arjuna first hit me this video. I got excited when she posted that, and whenever she posted those two books up, because I thought, great, she's going to be one of the rarest scientists who actually interacts with the works of people who deal with science versus pseudoscience. Because a lot of scientists like to comment on it, but very few actually deal in the literature on it. Unfortunately, she says she's not going to deal with that. She's just going to offer her own. And so that was a bit of an unfortunate thing, because many of the problems that I have had, and I think probably Arjuna has when he saw this, are actually addressed in these thinkers' works, which is an unfortunate thing. So looking at what she said in the video itself, she gives three criteria in that immediately. Now she shifts a bit, like I said, but the ones that you can pick out there is what makes science science is, number one, it has a model. Number two, it has data that matches the model to some greater or lesser extent. She'll go on with that. And number 3, it's simple. Now let's tackle those in order. Number 1, it has a model. There's a thing in science, in the philosophy of science, and it's called physics bias. Physics bias is basically defined as a bias towards the way physicists do research as the truest or purest form of science. There's a lot of ways that it's used outside of that, but we're going to work with that definition. And I think right there's a bit of a display of physics bias. And this isn't just my accusation. The normal way science is said to be performed is what's called the deductive nomenological model, which is you have a model, you have a law, and then you apply that to a certain empirical situation. And the biggest accusation against that has been, well, that works for physics, but that doesn't work for a lot of other fields. So for biology, biologists do work in models, but not all of biology works in models. If you want to study how cheetahs catch antelope, you go out, you observe it, and you observe behaviors and stuff like that. And that allows you to make predictions. There's no sort of universal model, though, at least not in the sense that you get in say, the physics departments with general relativity or the Freeman-Lemaitre model, the Big Bang cosmology. So model is being used very loosely there. And perhaps she can modify what she means by model to just any sort of explanation or sort, but it's really ill-defined. Either she's displaying physics bias, which is physics defines what science really is and everything else is sort of lesser than, or the term model is being used so loosely here that it really doesn't have a lot of meaning. So that's the first thing. Now let's talk about, does data fit a model? Does that what makes something scientific? She'll address it a little bit more as we go on, and I'll probably save comments until she says a little bit more on that. So number 3 is simplicity. And this is something Arjuna and I have talked about. What is simplicity? That's really, really difficult to say, well, this model is simpler than another. So for instance, in quantum physics, there's different interpretations of what's happening at the subatomic level. You have a sort of Copenhagen interpretation, you have a many worlds interpretation, you have deterministic models like the de Broglie-Bohm. There's about a dozen of these models, probably more. I'm aware of about a dozen. And all of them interpret the data differently. And every single one of those models says it is simpler because they're defining simplicity different. So a many worlds interpretation, which says that when quantum events happen, the universe literally, whenever the wave function of a quantum particle collapses, the universe literally splits in two. Well, the many worlds interpretation would say that's simpler. That's kind of, they're trying to read that out of the data. That's what the data in some sense seems to say to them. What other people are saying, the universe splitting in two doesn't seem like a simple explanation at all. Because to them, that's a very bare bones reading of the interpretation. When you have two probabilities, so let's two probabilities, and the wave function collapses and the particle assumes one of those two probabilities, what happens to the other probability? How do we make sense of a probabilistic, this sort of probabilistic reality that lies at the heart of all reality? And for them, it is when the wave function collapses, we need to understand that both realities are actualized, and we're only in the universe that we observe where one reality happens and not the other. That's extremely bare bones defense of that, because that would take a long time to sort of really hash out how they defend that. But to them, that's the simplest. We're just reading the data.
So if I go sit an exam and there's a possibility I'll fail it and a possibility I'll pass, does that create two universes, one where I pass it, one where I fail?
Yeah.
Seems like a weird way to read the data.
Collapsing a wave function, yeah. Okay. Yeah, that is.
Why did nobody come up with that before quantum physics? Because we've had exams for a lot longer than quantum physics, and nobody ever suggested that the multiverse idea, did they?
Unfortunately not.
Okay. Should we play?
That would have been a good excuse. One last, actually, no, let's go ahead. Let's keep going. I could go on for a while.
Is because the model captures certain patterns in the data, and any kind of pattern is a simplification. If we have such a model, we say it explains the data, or at least part of it. Visually speaking, a scientific model gives you a curve that connects data points. This is arguably oversimplified, but it is an instructive visualization because it tells you when a model stops being scientific. This happens if the model has so much freedom that it can fit any data, because then the model does not explain anything. You would be better off just collecting the data. This is also known as overfitting. If you have a model that has more free parameters as input than data to explain, you may as well not bother with that model. It's not scientific.
I mean, that seems to make sense. I was discussing this with Nathan Ormond of Digital Gnosis the other day. Like, if you have a, you could have one explanation for a motor vehicle which appeals to the laws of physics, and you break it down to very simple principles. And you could have another explanation that is, this thing has car essence, and car essence has all these properties. One of those sounds like science,
Right.
and one of them is just like an ad hoc, like, wow, you're just attributing all these attributes to the car essence, and you haven't really explained anything.
Yeah, I see what you're saying. Yeah, there are definitely explanations on a different level at the very least. One is very much more a scientific explanation. Yeah, and what she's appealing to here, this idea of what she calls overfitting, is a version, it sounds like, of Karl Popper's falsification. That in order for, because Karl Popper, this great titan in the philosophy of science, he abhorred the idea of Marxism and Freudianism being treated as scientific, because what he saw them doing is no matter what happened, they always had an explanation and said, hey, we made a false prediction, but really what actually happened actually proves our theory even more. And so no matter what happened, everything verified their theory. And so for him, a paradigm of a good scientific theory was Einstein and general relativity, who sort of put it out there and said, all right, during the solar eclipse, if we don't observe the bending of starlight, then my theory is absolutely false. It took a risk, took a real daring risk, and put itself out to be falsified. So that's why he's considered the father of falsificationism. And that's kind of what it sounds like, this idea of overfitting. If a model can fit everything, then it doesn't, if it can explain everything, it doesn't really explain anything.
Well, that sounds fair though, no?
Yeah, but the problem with falsificationism is it's while it's real popular among scientists, and you'll hear it, virtually every scientist will parrot it. Among philosophers of science, it's virtually universally rejected. And let me just give you an example. All metals dissolve in some form of acid. That seems like a scientific statement, at least bare bones, right? That seems like something that we could do. Problem is that you can't falsify it, because there could always be another metal out there that doesn't dissolve, just one we haven't discovered. Another problem would be black holes, right? Black holes, because there's only a finite number of observers around, black holes, before they were discovered, they were theorized. They were hypothesized, I should say, long before they were discovered. But how do you falsify that there's no black holes in all the universe? You can't ever do that. Believe in black holes today is not just from general relativity theory, but because we've had verification, which is the opposite. There's data that verifies it. So there's plenty of scientific things that sort of squeeze through the cracks and make falsification as it just doesn't work. So I think a bare bones, it sounds good, but when it comes to like actually using it as a demarcation between science and pseudoscience, well, you're going to have to throw out a lot of stuff that you would normally say is scientific, and you'd also have to include stuff that you wouldn't want to say, which you would call pseudoscience. So since we've talked about intelligent design before, I'm no ID theorist, but ID theorists at least put themselves on the line and say, hey, the flagellum is irreducibly complex. There's no possible mechanism by which it could evolve. That's a falsifiable claim. In fact, people like Eugenie Scott have claimed to falsify it. And yet at the same time, she'll maintain that it's a pseudoscience.
Right.
So she'll say, and you'll hear them speaking out both sides of their mouth, that intelligent design theory is unfalsifiable. And yet then they'll try, like within the same talk, and I see this all the time, they'll try and falsify it. They'll give all this data to try and falsify it. And so, I mean, I've never really been on the ID bandwagon, and yet I've never really been on the ID bandwagon, but But it's always seemed more the philosophical basis of the theory has always felt stronger from the ID theorists. Now, empirical basis is a different story, but the philosophically, ID theorists I think make real good points.
But how are we going to exclude Marxism though? Because if you have an economic theory that's like, there's this about human nature and this about economics, and here's how we can achieve a utopia, and then you try it and it turns into a murderous dictatorship. Like, have we not falsified that theory at that stage?
Well, no, because what would a Marxist say? They would just say this is a certain instance. Yeah, right. Yeah.
Yeah, but if they can be specific enough that this is what they weren't doing and here's what we're going to do different next time, then it's like, okay, fair enough. You're suggesting something which hasn't been tried yet. This other idea has been tried. That one failed. If you have a new idea, we can look into that.
Right. Yeah. So, and that's what they'll do, right? They'll usually point to historical particularity. So a real famous example is Karl Marx and Marxists really predicted that the communist revolution would emerge in the most industrialized states because it's capitalism run amok that motivates, the gears of history, which will motivate the communist revolution and the overthrow of the proletariat by the bourgeoisie. Oversimplification again. But they predicted it would happen in Germany, England, France first. But where did it happen first?
Russia,
which was pre-industrial.
Yeah.
So was that a falsification of the theory? Well, no. They said what we forgot to predict was the charisma of a character like Vladimir Lenin, who was able to motivate it in a country that was pre-industrial far before it happened in the West. So not falsified, because they added in this. Now, here's the funny thing. Now, we can make fun of that and laugh at that, but scientists do the same thing. So, for instance, Newtonian theory, well accepted, had a lot of verifying evidence, but then when they looked at the orbit, of the outer planets, they noticed, hey, Uranus's orbit is off. So, what'd they do? Did they abandon Newtonian theory because it didn't match the data? Because she's talking about models. This brings us back to the video. She's talking about models. Here's a data point that very clearly seems to contradict Newtonian theory. Did they abandon Newtonian theory? Was it falsified? No, they just said there must be an undiscovered new planet out there that exists. So Newtonian theory is preventing itself from being falsified by adding in this post hoc assumption. And guess what, though? It turned out to be right. That planet was Neptune. So scientists do this too. And today we see it with general relativity. There's certain things like the large-scale structure of galaxies don't make sense on general relativity. So we include dark matter, this undiscovered, invisible matter that makes up the vast majority of matter in the universe is causing all of this. And that's literally just a post hoc assumption. But there probably is dark matter. So scientists do this as well. Scientists add in assumptions, just like the Marxists did, to prevent their theories from being falsified. So if we're going, so to go back to Karl Popper's example, yeah, scientists can put out things that are falsified, but they often don't follow that. So again, falsification doesn't seem like it's a real good parameter. Does that make sense?
Yeah, but there's a distinction we want to make between dreaming and like ideology, and so you can have some idea like, like engineers are probably a classic example, because they're like, maybe I can build a bridge this way. So they get out there and they take some steel and some concrete and they construct it in different ways, and they like pound on it and stretch on it and shake it and do all sorts of things, and they figure out at what point does the steel break, at what point does the concrete crumble. And then they figure out how to build bridges that are safe. And every now and again, they get it wrong, and the bridge rusts or falls over before it was supposed to. But then they revise their theories. But the point is, their theories are constrained by reality. This is a saying from Thomas Sowell. He always talks about, ideas being constrained by reality. And the ex-Prime Minister of Canada, Stephen Harper, he thinks the difference between the left and the right can be, simplified, obviously, a simplification, that the left is trying to squeeze ideals onto reality, and the conservatives are, it's just seeing what works and going with that. And obviously there's we need both, right? We need to try new things, but we also need to see, well, this worked in the past, this didn't, so let's do things this way. And if we don't have that, the constrained by reality element, we just have ideology, then you get decades and decades and decades of raising teaching strategies or raising children strategies or economic strategies which don't work, but we're continuing to do them because nobody ever bothered to check what the consequences of these policies are.
Right. Yeah. So I think the main focus that you're talking there is constrained by reality. Great. Absolutely. The question is how are we constrained? What is the method that constrains us, right? And, is it falsificationism? Is it verificationism? Is it fruitfulness of scientific theories? And I think that's exactly where the demarcation problem really emerges, right? Is because I would say that theology and philosophy try to be constrained by reality. If not, then something's run amok. They try to constrain themselves by reality, but neither of us would probably say, yeah, that makes them science. At least not in like the natural science that we mean, that we're talking about here.
Right, yeah.
So
I guess it gets messy, but you definitely need that element in there for something to be science. So it could be necessary, but not sufficient, perhaps.
Mm-hmm. So that constrained by, oh yeah, absolutely. Yeah, I'm pretty sure that's uncontroversial. That's one thing we can definitely agree on.
Right. Shall we play more clips?
Sure thing.
There's something else one can learn from this simple image, which is that making a model more complicated will generally allow a better fit to the data. So if one asks what is the best explanation of a set of data, one has to ask, when does adding another parameter not justify the slightly better fit to the data you'd get from it? For our purposes, it does not matter just exactly how to calculate this, so let me just say that there are statistical methods to evaluate exactly this. This means we can quantify how well a model explains data. Now, all of what I just said was very quantitative, and not in all disciplines of science are models quantitative. But the general point holds. If you have a model that requires many assumptions to explain few observations, and if you hold on to that model, even though there is a simpler explanation, then that is unscientific. And needless to say, if you have a model that does not explain any observation, then that is also not scientific. The scientific explanations are the simple ones.
Yeah, so there's a lot there. She moves from point to point real quickly, so it's tough.
I've chopped it up.
So
too.
I think the first. Oh, did you?
Yeah.
Okay. I think even in the original, she does. I remember trying to.
I chopped out fillers, so yeah.
Great. Well, I'm glad. So first off, there are ways to determine. So sometimes simplicity and matching with the data compete with one another. Now, here's the problem. I don't think either of those are good metrics. Here, I'll lay it on the line. I don't think either of those are good metrics. One, because for simplicity, for the problems that I've already laid out with simplicity. Two is quite often reality is more complex than we'd like. So there are instances where the more complex model has won out in science. And let's see, what was the other thing? Okay, we'll go ahead. That's for simplicity. So matching with data as well. What that would mean, though, is that no one could ever make a bold hypothesis.
So
that doesn't fit the data, but makes testable predictions that might in the future predict the data. That for her, any bold hypothesis would be considered pseudoscience, which just doesn't make sense. So for instance, prior to the discovery of the cosmic microwave background radiation, there was little evidence for the Big Bang over the steady state, over models of an eternal universe that Einstein himself had proposed, that he postulated this dark energy, this cosmological constant, which kept the universe eternal and kept it from either inflating or contracting. What that model did, though, is it posited something new. Einstein posited something new, a cosmological constant. It added something in order to preserve an eternal universe, rather than getting the Friedmann-Lemaitre model, which ended up proving to be correct. Was Albert Einstein a pseudoscientist because his theory wasn't as simple. And here's another thing. Both equally matched the data, right? But one made predictions that the other one did not. And quite often we get that in science. We get these models that make predictions that don't quite match the data, and they turn out to be correct. Copernicus's heliocentric theory fit the data less perfectly than Ptolemaeus's geocentric theory when it first came out. In fact, it was horribly wrong. And that was one of the first accusations against it. Copernicus turned out to be right. So those are two examples. The first one dealing with simplicity and a little bit with fitting with the data, because both fit the data, right? And the second one deals specifically with the data, namely the fact that Copernicus's ideas, which are considered an ideal of scientific advance, would have been considered pseudoscience by Sabine's own criteria because it did not match the data as well as the Ptolemaic model. And it left a lot of things unexplained. Like, for instance, if the Earth is moving around the sun, when I throw a ball up, why doesn't it go flying away if we're traveling at such high speeds? This was prior to Newton's laws, objects in motion stay in motion. Remember that. So for them, that made natural sense. That was the understanding of the world at the time. So it didn't match the data. Also, why do stars, if we're going around the sun in this very large orbit, why don't the stars move in the sky? If I look up at my ceiling and I stare at one point, if I move around in the room, that point will look like it moves with me. And so Copernicus, in order to save that, it's called stellar parallax. Copernicus, in order to save that, had to say, these stars are so far away that we just can't pick it up. That was his explanation. And that was the going explanation for a long time. That sounds like an ad hoc way of saving a theory, which doesn't even match the data of the Ptolemaic theory. It was right. And that was considered a thing of scientific advance. So fitting with models rules out bold scientific advances like Copernicus. That would be considered an instance of pseudoscience. And simplicity would also rule out things. It would make people like Albert Einstein pseudoscientific.
So didn't Einstein say a theory should be as simple as possible, but no simpler?
I'm not familiar with that quotation. I wouldn't be surprised with it, though.
But that quote would support, so Einstein's theory wasn't simpler, but the other theories were too simple because they couldn't explain as much.
Einstein's theories weren't simpler.
Yeah, they were more complex,
so
but the other theories were too simple.
Yeah, so what he did is he added, he was more complex because it added in a mysterious unseen force.
But it was necessary to add that in order to get the explanatory power, and therefore, based on, as simple as possible, but no simpler as the criteria, that explains Einstein's theory being scientific.
Yeah, so that would make the Friedel-Lemaitre model, the idea the universe was expanding, which Einstein didn't like, that would make that was the more simple idea. It just took it bare bones. It didn't add in any mysterious forces. Einstein added in a mysterious force. His model was less simple. It was proven false, but at that time, it was less simple. Now, according to Sabine's own criteria, Albert Einstein would have been acting as a pseudoscientist right there. And no scientist would say that. He's a paradigmatic case of a scientist.
I wonder if we should jump to the T-Jump clip where he talks about falsification, or just continue on with Sabine, because that's related to what we're just saying.
Yeah, we can jump. We can jump wherever you want. You know me, I can talk all day on this.
This clip's a little bit long, but it's fun.
So what do you mean by confirmed?
I recorded these off YouTube with screen grab to get them, and I think I had the sound a bit hot, so unfortunately it's clipping a little bit. My apologies.
You need some methodology to differentiate imagination from reality. That would be confirmation.
Okay, so we just need some kind of independent reason for it. Is that what you're saying?
Well, just any methodology that can accurately differentiate imagination from reality. So that would be the same thing as a reason. It's just definitionally the same, but it wouldn't just be an argument you could present. You'd have to actually present something sufficient that would qualify as a successful methodology that can accurately differentiate imagination from reality. So whatever methodology you're going to propose, we're going to have to test this methodology against other things in the world and say, well, does this work to differentiate against imagination and reality in these cases? If no, then it's not reliable in this case either. So you'd have to present some methodology that can independently differentiate imagination from reality in lots of other cases. And then if it can do that, we can infer that it could in this case too.
What if I told you that, like, Here's one reason that I think moral realism is true. I think that it just seems obvious to me that Jews have value regardless of what Nazis or what other people will say. So it just seems obvious. What do you think about that kind of reason?
It seems obvious to me that this cup is solid, but we know that's false because it's 99% empty space. The fact that it seems obvious to you is just your imagination. All it does is it brings it forward as is this one of the imaginary or one of the real things?
I just want to explain that there. So I like the point Joe Schid's making about, like, we have intuitions. Like, he's basically making a case for phenomenal conservatism, that some things just seem to be the case. So phenomenal conservatism is we are justified in accepting something as true, provided we don't have a defeater for it, if it seems to be true. So it seems, he gives the example, it seems to me that Jews have value regardless of what Nazis or anybody else thinks about them. And that seems perfectly good to me. And then T-Jump is replying saying, well, our intuitions have been wrong so many times. For example, our intuitions tells us this cup's solid and it's not. And there's many other cases that are given of our intuitions being wrong. One point where that fails is that our intuition, the cup is solid. Our intuitions fail in areas where we don't have experience. So, our intuitions about infinities, like there's like Hilbert's Hotel and all sorts of like weird things about infinite sets of numbers that just boggle. They contradict our intuitions, and things about tiny things and large things of which we have no experience, and tiny timescales and infinite timescales of which we have no experience. That's where our intuitions break down. But our intuitions work fine and have never been debunked, as far as I can see, by science and the realm where we have lots of experience.
Yeah. There's a couple points. I mean, first off, Joe Smith's absolutely right. When you say something is solid, you're not saying it's not made of empty space. You're just saying it's solid, right? It's creating an electromagnetic repulsion whenever you touch it, rather than you passing through the object. So
what do we mean by
what
solid?
solidity is. Yeah, I mean, that's exactly what the understanding now that atoms are mostly empty space hasn't disproven that there's such a state as being solid. Obviously, that's still something physicists use. That's pretty self-explanatory. And also, it just doesn't work, period, because epistemologically we understand, like Joe Smith appealed to intuitions. Yeah, moral intuitions. We have a good reason for believing in moral values. We're way away from the demarcation problem here, but I think it's related. We have a good reason for believing that. I just have a moral intuition about that. In the same way that I'm looking at a computer screen right now, and I think there's a real computer screen in front of me. Could there be something that defeats that? Yeah, I could be in the Matrix. I could be hallucinating right now. My wife could have put something in my breakfast this morning. Who knows? Especially with her. I'm sorry, honey. But hopefully she never watches this. But that's the thing, though. Unless and until you have that, you're rational in maintaining that, and perhaps even irrational in not maintaining the bare bones witness of your intuitions, of these direct experiences. So the fact that T-Jump says, well, I had this experience. So even if he's right that the cup's not solid, let's just grant him that. Well, the cup's not solid because there's empty space in the thing. Great. That is exactly what sort of thing happens. What sort of thing happen? What sort of analogy do you have with morality that can undermine it? Just because intuitions can be shown to be wrong doesn't mean you're therefore granted the ability. It would be like saying, well, we've learned that cups aren't solid, therefore I believe I'm in the Matrix. Like, that does not follow logically.
Yeah, right. Well, I mean, it's a kind of fallibilism, right? Like, we could be wrong. We could be in the Matrix, but like, you just add that as a caveat that, like, when we say we know something or we say we believe something to be true, there's this little footnote that, sure, we could be in the Matrix, but we're justified in holding this belief and it would be unreasonable to doubt it.
Right, exactly.
I'll continue with the clip. Yeah, I love this little section because Joe Schmid did such a good job of pushing back on it. This is a talking point for T-Jump. And I think I noticed after this discussion, T-Jump sort of changed his tune a little bit. He didn't do it in the discussion, but later on he didn't push the same talking point in quite the same way.
That's all it does. It doesn't give you a way to differentiate between the two. It just provides you with evidence it's one of those two. I take the second approach you mentioned. So we have rational defeaters for any basic belief who say most of our beliefs were always wrong. We pretty much throughout all human history, every one of our beliefs was completely wrong. And the way we figured it out was we have we imagine the way things are. Lots of people imagine like what knocked over that cup. Maybe it was a bird, maybe it was a squirrel, maybe it was the flying juju under the sea, or a lightning bolt, or an invisible alien. There's infinitely many things that could explain what knocked over that cup, and everybody in the tribe thinks it's a different thing. But the one who gets it right can say, if I'm right, I can predict something we don't know yet, and we can discover it. You have to predict something we don't already know yet. Like if I predict the sun's going to come up tomorrow, therefore the spaghetti monster is real, like obviously no one's going to believe it.
I cut out a bit where Joe Schmidt gave an argument like, I can do it right now. I can predict that if I drop this pen, it will prove that there's a real pen. And I can make the same prediction, but say that it will prove that there's not a real pen. I'm just hallucinating the pen. And I drop the pen and it falls. And then T-Jump replies saying, no, you have to predict something that we don't already know is going to happen. So
that, or if I predict the numbers of last week's lottery numbers, like obviously that's not going to be evidence of whatever I'm saying. It has to be a prediction of something we don't know yet. So if you can predict something we don't know yet, then it would be evidence. So for example, if you came up with a hypothesis that the magical genie exists, therefore we're going to discover dark matter is made of magical pink puppies, and you make another hypothesis that we're not in a delusionary hypothesis and there's magical pink puppies that are actually causing dark matter, and we discover that dark matter is caused by magical pink puppies, then both of those hypotheses would be equally supported until we made new novel predictions to differentiate between the two.
There are some pieces of data that we actually do know, and we come to have evidence for hypothesis on the basis of it's being able to predict or explain the thing that we already knew, but which other hypotheses weren't able to explain it. So for instance, that happens all the time in science. We have, for instance, the retrograde motion of the planets, for instance. The Ptolemaic system was not able to account for that, or it had to use these really ad hoc postulations to account for that. And so we knew that this data was there all along. But then we came up with, like Newtonian, gravitational theory and so on, and that was actually able to accommodate that past data that we had already known. It's not a novel prediction. We had already known that, and it's able to accommodate that better than all of its rivals, and thereby it gains evidential justification. Per every single philosopher of science would say that it gains evidential justification on the basis of that, even though it's not a prediction.
No, not really. So that's actually wrong. It gains some very minimal kind of useless kind, but the reason it's really accepted is the novel testable predictions. That's why it's accepted, is that once we take this model and apply it, we get new, more accurate data. That's better, not the fact that it just explains everything.
That was not your claim. Your claim originally was that it does not confer evidence towards it.
Yeah, for my epistemology, I don't even care about it. I'll discount that immediately. I don't care at all. It counts as nothing for me. It only counts as evidence if it's a novel testable prediction in my epistemology.
But now that's just a reductio, right? Like everyone agrees that Newtonian theories predicting, not predicting, but being able to account for that retrograde motion of the planets that none of the other ones in the past were able to account for, everyone agrees that that's evidence for it. That's some reason to think that is true, that it accounts for those better than all of its rivals, and that it's able to go back and be able to predict something that we already knew.
Well, no, again, the reason it was accepted was not that. That was not.
Think about
I understand what you're saying, but that's not the reason it's ever accepted in science. No one cares about that.
We're not talking about acceptance. We're talking about evidential confirmation. It provides some evidence for it, which is what you just denied.
Right. So in mine, is this what qualifies as acceptance verification is just the testable predictions, never the fact that it can post-dict anything. I don't care about that at all. So mine will never accept that as evidence, and no one in the consensus will either. The consensus of experts only accept it with the novel testable predictions, never the post-diction. Like every model in quantum mechanics can post-dict all of the experimental data in quantum mechanics. No one accepts them. No one cares. None of them are accepted because they don't make novel testable predictions. The criterion in science of acceptance and what qualifies as real evidence is, can it make novel testable predictions? And if it can't, it's nothing. That is the standard in science, and that is my standard too. The fact that some philosophers will count it as evidence, their standard of evidence is far lower than that of real scientific data, whereas mine isn't. Mine is novel testable predictions or go home. So even though some philosophers may count that as evidence, some minuscule amount of evidence, I definitely don't, and science definitely doesn't.
It's a little long, but anyway.
Yeah, well, there's a lot there. And I cannot, like, T-Jump makes, occasionally will make some good points. This is not one of them, unfortunately. So one of the things, so he stakes his claim that this is what scientists do. And he's like, I am standing on with science, some abstract person named science, I suppose, because science is never unified on virtually anything. But he's saying this is what scientists do. Nobody does this. And he's sort of challenging Joe Smith that I'm on the side of science. They don't do retrodiction, or I think they call them postdiction in that video. It just does not do that. And Joe Smith very rightly points out that is exactly why Newtonianism was accepted. That is exactly why a ton of theories in science were. Honestly, most of Darwinian theories, Darwinian theory was accepted because it explained things after the fact. They looked at the fossil record and they said, hey, we see a succession of things. Evolution explains this. Darwinism gives us a mechanism for that. I think we're getting some feedback. You're right.
I'm just trying to I'm just trying to find that other clip that I hadn't found already. And
okay. So
I wonder if I just I'll
keep going.
Yeah, you can keep going.
Okay, yeah. So let's just take 2 points because there's so much here. First off, science we only know something if it can make a prediction. This is a real well known in philosophy of science how problematic this is. If it can make a prediction, something new, novel that we don't know, and lo and behold, it turns out to be true. So let's make the prediction that let's say substance X is green, and we define green as the color green, right? But let's also make the prediction that this substance X is GRU. And by GRU, and it's in philosophy of science, this is used a lot. GRU, I'm defining as something that is green until the year 3000. And then after the year 3000, it transforms and is blue. Now, let's go out and look at substance X. And every instance we get of, let's say every instance we get of substance X is, guess what? It's the color green in the year 2021. So it equally supports both that substance X is green and that substance X is GRU. So what does that show us? That's sort of a silly illustration, but it's used all the time. But it shows us that you can create an infinite number of predictions that will equally accord with the data. And this is what Quine called the underdetermination problem. That there's always these assumptions, there's always these things built into science, and and somehow we're working out in our mind things that are not just, does it match the data? And that's also a problem with Sabine as well. There's a lot more stuff going into that why we think a substance X, well, it's green. We have no reason to think it's going to turn blue after the year 3000. So we're packing in more than just fits with the data. And that's a problem with T-jumps as well. So that's an immediate problem with that, is it's not exhaustive because there's an infinite number of predictions that can always fit with the data. So it's at the very least, it's incomplete. But I think a bigger issue is science does not use retrodiction, postdiction. I've talked a little bit about that before. He gives the example of the different models of quantum physics. Since I already brought that up, I'll use that. Right. The reason that one is not preferred over the other is not that they all postdict or predict the same thing. They all also equally predict the same results. So even by his own standard, his own standards, like, it just doesn't work. These things are making predictions. These models are making predictions. The many worlds interpretation and the Copenhagen interpretation make the same predictions for future scientific discovery. So simply just ruling them out based on retrodiction, that's not the case. Scientists use retrodiction explanations all the time. Absolutely all the time. So for instance, if they go in, an archaeologist goes in, there's no prediction, and they go in, they discover a lost city. No prediction, right? But then they retrodictively say, oh my goodness, I guess civilization X must have settled here. This comes after all the data. Is that not real? Is that not a scientific explanation?
Right.
Well, according to T-jump, no, you can't do that. You can't know that for certain because you didn't predict it ahead of time. So it's just it's absolute absurdity, that sort of position, that retrodiction, postdiction
unless
doesn't
you say
work. Scientists don't.
A civilization lived here, in 300 BC. We'll dig and we'll find it. Then when you dig and find evidence of that civilization, it's not evidence for that civilization because you didn't predict it.
Yeah, exactly. Yeah, and then you would just say, I don't know what he would say, honestly.
That's a really good
because all data all data would, all explanations of that would all be retrodictive. They would all be postdictive. So nothing could ever explain that, according to T-jump, I suppose.
Well, the funniest thing is that Joe Schmidt actually made a really good counterexample, which was that T-jump was doing postdiction. He was saying previously you know, when Teachup was making an argument for his epistemology, he was saying, this is how science has worked in the past. We've made so much progress in science through prediction. It's like, you just did retrodiction right then and there when you made a case for your epistemology. So if you need to use retrodiction to make a case for your epistemology, then I don't think your epistemology is coherent.
Well, no, it's absolutely not. That's a great point.
All right, so should we jump back to Sabine?
I will say this. There's a well-known debating tactic, and I see it from Teachup. I see it from a lot of people, no matter what where they're at on the religious spectrum, which is if you have a point and you don't have a reply, drop it and hope they forget about it.
Yeah,
and it sounds exactly like what I mean. Having listened to the debate, that sound like watching him sort of
just don't reply to it.
Yeah. Just let it pass.
Yeah, and reply. Well, that's what red herrings are.
Yeah.
Which was,
yeah, you lead them on a different path. That's
yeah, you can try. Yeah, that's these really good rhetoricians. They'll just steer the conversation wherever they want it to go, and you might be way better at philosophy and have the science on your side and everything. But if you don't know how to steer the conversation and keep it on track, I heard a really good analogy for it, that a small dog can beat a big dog in a fight if it does one thing: it bites onto the dog and never lets go. So that's a really good debate strategy. You know, you find your strong point, you find your interlocutor's weakness, and you just don't let go. You just drive that point home all the way through. You know, like normal philosophers, like a gentlemanly discussion, you'll discuss the point, you'll discuss the weakness, and then you'll just discuss everything because that point was discussed, and you move on to other subjects because you want to have an interesting discussion. You want to cover some ground. But in like a public debate where you're trying to defeat the other person, that's not what you do. You sort of rub their nose in it and you just drive it home and keep driving the same point. All right, some more, Sabine.
The ones that explain lots of observations with few assumptions. Let us look at some other popular example, Darwinian evolution. Darwinian evolution is a good scientific theory because it connects the dots, basically by telling you how certain organisms evolved from each other. I think that in principle it should be possible to quantify this fit to data, but arguably no one has done that. Creationism, on the other hand, simply posits that Earth was created with everything in place. That means creationism puts in as much information as you get out of it. It therefore does not explain anything. This does not mean it's wrong, but it means it is unscientific. Another way to tell pseudoscience from science is that a lot of pseudoscientists like to brag with making predictions. But just because you have a model that makes predictions does not mean it's scientific. And the opposite is also true. Just because a model does not make predictions does not mean it is not scientific. This is because it does not take much to make a prediction. I can predict, for example, that one of your relatives will fall ill in the coming week. And just coincidentally, this will be correct for some of you. Are you impressed? Probably not. Why? Because to demonstrate that this prediction was scientific, I'd have to show it was better than a random guess. For this, I'd have to tell you what model I used and what the assumptions were. But of course, I didn't have a model, I just made a guess. And the simplest explanation that I was right is that I was coincidentally right. A model that does not make predictions can still be scientific if it explains a lot of already existing data. Pandemic models are actually a good example for scientific models which do not make predictions. It is basically impossible to make predictions for the spread of infectious diseases because that spread depends on policy decisions which themselves cannot be predicted. So with pandemic models, we really make projections, or we can look at certain scenarios that are if-then cases. If we do not cancel large events, then the spread will likely look like this. If we do cancel them, the spread will more likely look like that. It's not a prediction because we cannot predict whether large events will be cancelled, but that does not make these models unscientific. They are scientific because they accurately describe the spread of epidemics on record. These are simple explanations that fit a lot of data, and that's why we use them in the first place.
Should we pause there?
Yeah, a couple points. First one, she's talking about Darwinian theory versus creation. Now, I'm obviously sympathetic to evolutionary theory, but I don't know what she meant by creationism puts in as much information as it gets out. Maybe you understood that. Because
I think it's
I
like
wasn't sure what that meant.
the car essence theory kind of thing. So if you say, oh, we've got this world, and how do we explain it? It's like, oh, God just created the world this way. Oh, and why are things this way? Oh, God just chose to create things that way. So basically, for every feature of the world you have, you just ad hoc say God did it. I think it's kind of similar to the car essence thing. So instead of having a simple theory of the physics that makes motor vehicles function, you just appeal to car essence. You're putting in as much information as you're getting out. Whereas the laws of physics, you can, if you understand the laws of physics well, you could figure out how to create a car. The car is complex, but the laws of physics are simpler than the car.
Yeah, so it's kind of that idea that the model fits. If a model can fit everything, then it doesn't explain anything in particular. Right. I would think that maybe in a sort of general circumstance, creation could, but in any sort of scientific case, they normally limit it down. So, for instance, intelligent design would say that the Darwinian ability to explain all forms of life would count as absolutely, that would show that it's superior to a scientific hypothesis to intelligent design. I think most adherents would probably adhere to that. So there is a sort of level of falsification within that. So yes, creationism maybe sort of generically could, but any sort of scientific case, at least from what I've seen from their literature, could probably overcome that objection.
Yeah, I mean, I imagine a lot of these people who oppose intelligent design haven't read the quality literature on the subject. They see it railed against, and they hear from the critics, but they haven't actually studied the strong defenses of it.
Unfortunately, I think you're right. I really do think you're right. Again, I keep repeating this. I'm going to sound like an intelligent design apologist when I'm not, but the literature I see on that, I think Ken Miller is a good exception, but then you see like Francisco Ayala's debate with William Lane Craig, and he's using the I as an example of irreducible complexity when Michael Behe explicitly denied that the I was an example of irreducible complexity. It's just that sort of lack of familiarity. I was actually in a lecture a few years back at Oxford where a guy gave a lecture on why intelligent design theory is bad theology, along with bad science. So he sort of tried to kill two birds with one stone. But he kept using the term that they postulate a supernatural cause. And at the end of the lecture, I pointed out, I said, well, you do realize that intelligent design theorists don't say it's a supernatural cause. They're actually quite explicit, like in virtually any of the literature you read, they're quite explicitly say that it could be a natural cause. Like they have people within their ranks who don't think it's a supernatural cause. And it could be a space alien, for instance, just as a kind of absurd example. And he says, well, I'm using the term supernatural to include aliens and those sorts of things. And I said, okay, all right. Supernatural aliens. So I sat down. I didn't push the issue, obviously. But I think that was a sort of like he had realized he had made that mistake. But that just shows an unfamiliarity. People are very willing to criticize a position without actually looking at the actual claims of it. So all that, moving on, I think there's legitimate critiques of intelligent design theory. I just don't think you'll find them in the usual places, unfortunately. So the second point that she talked about how this was a kind of a weird thing. She talked about how a scientific model doesn't necessarily need to make correct predictions to be scientific. And I thought that was odd because if you remember, I pointed out early on, she gave three principles. She gave it needs to be a model, it needs to fit with data, and it needs simplicity. And she unfortunately she used the pandemic modeling, and I think she goes on to use weather modeling, which has severely at times underestimated or overestimated how bad the cases have been. So I remember just a couple months ago here in the US, it was predicted by at this point we would have 0 cases or next to 0 cases, virtually none. That's not the case. It's because something that the model didn't take into account entered in. And this is not the first time that these models have been wrong. So by her own criteria, it doesn't fit the data, so it wouldn't be scientific. Now, I'm not saying that I do think these models are scientific. I think that this shows a problem in her criteria. That the fact that things can be revised, like weather patterns are continually, but I think she tries to save herself by saying, well, we're using the best data from the past. Retrodiction, the thing T-Jump hated. So there's an example of a scientist using it, right?
Right.
Yeah, it's a very clear example. She tries to save it by saying that. But then if a scientific theory is continually making incorrect predictions, when something she can't address and doesn't address, I don't think there is an answer to it, is when do you simply say the model is wrong? And when do you keep accommodating new data for the model? And there's no good answer to that. So for instance, I gave the answer of Newtonianism. When is it okay to say Newtonianism is wrong because it incorrectly predicted the orbit of Uranus? And when is it okay to say, no, it's probably right, we just have to find a way to fit something, like add a new planet in order to fit it with the data? There's no good answer to this. And so using it as a criterion for marking science from pseudoscience is just wrong, because there's no good criterion for that.
Well, I would say with Newtonian physics, it's not that it's been debunked. It's just that we've figured out the limitations of it, that it applies, to large bodies at slower speeds, whereas for tiny things or things at high speeds, it doesn't apply. You need something else.
Right. Yeah. So I'm talking about back in the day when they tracked the orbit of Uranus and it didn't match Newtonian physics. They didn't reject it and say it was falsified.
Right.
They predicted a new planet, which was discovered in the 1800s, which was Neptune, which was affecting the orbit of Uranus. So they ended up saying, we're not going to falsify the theory based on the data. So sometimes that's okay, sometimes that's not. There's no good way of demarcating when that's okay and when that's not okay. So using that to try to demarcate science from pseudoscience is simply wrong, because the area is fuzzy within science itself.
So you were saying that climate science has made many false predictions and revised their models numerous times. So her example of weather is faulty.
Well, I mean, yeah, we see how difficult it is to predict weather every time we turn on the morning news. How often has your weatherman been wrong?
I live in a maritime climate.
My mom used
In New Zealand, nobody takes the weatherman seriously. Actually, it was funny. I heard someone that talked to someone who was a meteorologist that had just moved to New Zealand, and he was telling them, you do know nobody in New Zealand takes the weather forecast seriously. They're like, no, of course it's not true, because they were like from America or somewhere where like you can kind of predict the weather, but in New Zealand it's maritime. Like there's just a bunch of clouds blowing around in the wind. Like, there's no mountains to catch or anything. Like they predict a major storm and the storm just like goes straight over and doesn't even stop. We don't get to see the storm at all. Like all sorts of things like that happens. And this person actually, I think, got really disillusioned, and like they might have quit their job as a result. Like they thought they were doing something meaningful, but they found out in New Zealand nobody cares about the weather forecast, and they were real dejected.
Yeah, I mean, I grew up in the Midwest where we have a joke: if you don't like the weather, wait 15 minutes.
Oh, right.
So that's the sort of weather I grew up. So yeah, so I understand incorrect weather predictions, but no matter how many times meteorologists get this wrong, we're never going to say meteorology is a bad science.
Yeah, it's true. Yeah,
it's sort of built into the assumption that you could be wrong a lot.
Well, it's just too many unknown variables.
Yeah. That's the thing. There's a lot of unknown variables, but that's like sciences develop, right? The more you learn. So physics, general relativity, there's not a lot of unknown variable. There shouldn't be. It's sort of built into the model. We understand how it works to ridiculous precision. But when it comes to meteorology, chaos effects comes into play, and it's much more difficult to predict. So what that basically tells us is that predictability for infant sciences, for sciences that aren't quite as advanced, predictability is not that big a deal. It doesn't necessarily have to be right all the time. And we'll still say, well, we're making progress. We're using models. We're gathering data. Eventually, hopefully, it'll get better. It's just promissory note that these scientists give that eventually will be predictively successful, kind of like these other fields of science. So predictive success, again, that's another, like, just, I mean, we're bouncing around, but that's another problem for trying to demarcate these sciences. So, for instance, people say astrology is not a science because and I'm no astrologist, that it's not a science because it's not predictively successful. We'll ask an astrologer, and he says, well, it's because, we don't have a lot of people working in our field. It's because it's very difficult, because how many stellar and objects are we working with? And planetary objects are we working with? Tons. The data is extreme. It's like meteorology. And they would even claim that there has been advances over the past few thousand years. I know I've heard these claims from astrologers that they think they have advanced as a field, just in the exact same way like meteorologists or climatologists have. So again, this just shows how difficult it is demarcating science from pseudoscience.
I mean, it's a theologian might claim the same thing. Like you say, you follow this process and you'll get some experience of God. Someone follows that process and doesn't get the experience, and you just say, well, you weren't doing it right. There's a lot of subtle variables, your intention, so many variables go into, and God is also a person. He chooses whether or not to reveal himself or appear. And so just because it didn't work for one person, it's worked for millions of other people all through history. Just because it didn't work for a few people, it doesn't debunk it.
Right. And it's impossible to know when there's no, I shouldn't say it's impossible. There's just no clear-cut line of when this sort of reasoning is okay and when it's not. Science has not given us this sort of good demarcation line. In some fields this is okay, in some fields it's not. And it's just, this is how scientists practice without any sort of rigid methodological outline for when it is okay to be predictive, when predictive success is considered super important and when it's not.
All right, so I've got one more clip from Sabine. I'm not sure if it's the part where she talks about the weather or not.
So if you want to know whether a model is scientific, ask how much data it can correctly reproduce and how many assumptions were required for this. Having said that, it can be difficult to tell science from pseudoscience if an idea has not yet been fully developed and you're constantly being told it's promising, but no one can ever actually show the model fits to data because they say they are not done with the research. We see this in the foundations of physics, most prominently with string theory. String theory, if it would work as advertised, could be good science. But string theorists never seem to get to the point where the idea would actually be useful. In this case, then, the question is really a different one, namely, how much time and money should you throw at a certain research direction to even find out whether it's science or pseudoscience? And that, ultimately, is a decision that falls to those who fund that research. Thanks for watching. See you next week.
I think there is a real telling admission right there. How much do you fund into a project to find out whether or not it's science or pseudoscience? As if we don't know at this point. Like, that's not how pseudoscience. So she's using pseudoscience really. I think this reveals a lot. She's using pseudoscience in a pretty idiosyncratic, unique way, because scientists want to say this at the very beginning. These fields are scientific, these fields are not, and demarcate the line very clearly from the start. They don't want to say, my studies might be pseudoscientific, or they might be scientific. It'll all depend on what future results show up, based on whether or not they can come up with good models, good predictions, and stuff like that. That's not a very good demarcating line, because that would mean scientists don't know whether or not they're doing science or not. So I wasn't sure exactly how to interpret those last couple lines, but it definitely seems like she's introducing a really problematic element into that.
Someone's making a point about astrology. I think the issue with astrology is that it can't even demonstrate the mechanisms by which any of it should work.
So here's the thing. In science, you don't need to show a mechanism. When I've made this point to Arjuna, I think right before, is when Newton, again, the paradigmatic case of science, the paradigmatic case is Newtonian mechanics, postulated his theory of gravity. Leibniz accused him, the co-inventor of calculus, accused him of introducing occult forces into science because he could not explain the mechanism by which gravity could affect objects at a distance. It seemed like magic. And until we actually got to Einstein, we didn't really have a mechanism. But again, Newtonianism is a paradigmatic case of science. This is what the philosophers of science use as the example of this is good science, and pose it against, say, things like astrology, right? So having a mechanism isn't necessary, because again, Newtonian mechanics didn't have a mechanism for how gravity worked.
Electromagnetism and electrons interacting also doesn't have a mechanism. We know it happens, but we have no idea how, because I mean, this is a point that relates to the mind-body interaction problem for dualism, that, well, if they're two categorically different things, then how can they interact? Well, it's like electrons and electromagnetic fields are categorically different things. So how do they interact? That's never stopped us from treating electromagnetism like a science.
Yeah, and here's another thing. Quantum phenomena is filled with unexplained mechanisms. So, for instance,
spooky action
with
at a
non-local
distance.
realism. Yeah, spooky action at a distance. We don't know. That's scientific. We're not going to call that. We're not going to put that in the same classification as astrology.
Sweet. So the next clip is that John Wilkins one. Should I play that?
Sure.
But what makes something good science, only time will tell. And if something has been pushed again and again, for example, the design argument in intelligent design, it's been pushed for about 2.5 centuries and made zero progress. Now, there is a scant chance that intelligent design views will suddenly start delivering promising scientific research. But if I were a betting man, I wouldn't put any money on it, right? Whereas string theory, well, I think the jury is still out. I know people who are ardent string theorists, and I know people who think that it's a complete and utter waste of physics and money, and they should be putting their efforts into other things.
And I love this clip. I sent it to you because this is that promissory note. If something is scientific, well, we'll just have to find out, right? It has to advance. So the idea that science is built on whether or not it advances or not, that's pretty, that's a view put out by a guy named Imre Lakatos, who I think I mentioned earlier. There is a problem with that, is that when sciences become complete, the more complete they become, the less they progress. That's just something that happens, is whenever you complete a science, there's nothing more to progress toward. But that doesn't move things from scientific to pseudoscientific. And also, there seems to be the idea that whether or not something is scientific or pseudoscientific depends on the success of the scientists working within it. Something can move from being a pseudoscience to a science, just depending on how successful the scientists within it are. A third point would be that there have been plenty of things that have advanced. Again, I know astrologers who claim that they have advanced. I know ID theorists. I know he talks about he uses that, but I would say that a lot of ID theorists would claim that the idea of irreducible complexity and actually having a way of testing for that, at least what they would claim that's an advance. So I don't even think the examples he gave were good illustrations. And there was another entire field that existed within Germany and France for about 100 years. It was called the Naturphilosophie, where they had this a lot of forces, like it was a form of vitalism, if you know what that is, that there's a living force within life. And it made a guy named Timothy Lenore did an exhaustive history on them. And he pointed out that by Lakatos's own criteria of advancement, they advanced radically. They had a very thriving scientific program, but virtually all scientists today would call that entire program, the Naturphilosophie, they would call it pseudoscientific because it had these sort of life forces introduced within it, these non-naturalistic things that they've thought of as non-scientific. I could keep going on and on,
right.
But using advancement as a key is just, it doesn't work. You would have to introduce a lot of things. People who do psychic research, they would claim, they have entire journals where they claim they advance. So you would include a lot of things that you don't want to include and rule out a lot of things, fields that are mostly complete, like a whole range of chemistry hasn't changed much for decades. For over 100 years, there was not a single new noble gas found. Does that mean a scientist working in the noble gases was a pseudoscientist?
Right.
No. Yeah, but then again, in 2015, when they found a new one, is that scientist now suddenly a scientist again because someone found that? Yeah, so it's a terrible criteria.
Or like if Thomas Edison stopped short of discovering the light bulb, would he have not been doing science all along? Whereas if he managed to discover the light bulb, then all of it was science all along. Or maybe if he'd stopped short, he was doing science all along, but we just didn't know it because he didn't get through that last step of actually discovering the light bulb.
Yeah, it's too contingent upon the practitioners and like our motivations. It's a terrible criterion. Like our motivations will determine what we fund and what we try to advance.
Here's a question. I should bring this on this side. Sam RN is asking, I just finished a book by Aaron Yilmaz, a Christian evolutionist. He says quite strongly that ID folks do no research. What say you, Seth?
Well, again, I'm not an ID theorist, so I don't want to make their arguments for them, but they do claim that they do research. I know Jonathan Wells and Michael Behe. If you read Behe's The Edge of Evolution, he would consider that entire argument to be an argument for ID theory. And that would be an advance. That if you use the sort of design criterion set out by William Dembski, and start applying that to life forms, doing research on whether or not it meets that criteria that he set out, you can start coming to conclusions of whether or not something was intelligently designed or evolved. I could see that. I don't know if they're doing this, but again, whether or not something is a science or a pseudoscience shouldn't depend on what the scientists do. It should depend on the field itself. It should depend on whether or not, if all biologists today decided to quit and there were no biologists, biology shouldn't be a pseudoscience until people start doing research again. No, biology is a science one way or the other. And in the same way, whether, the question is whether or not it can do research, whether or not it actually is. And I think that at least an argument could be made for that.
There's a branch of science, I can't remember what it's called, where they learn from things they find in nature. So they'll study the cell or they'll study insects and how their bodies work, how things are achieved, and they'll use that to design a more aerodynamic car, a more aerodynamic aeroplane. And this would
biodynamics
could be biomimetics,
might be
I don't know.
Yeah, biomimetics. Yeah, I know what you're talking about.
This would seem to be the assumption. You could call this intelligent design research. We're assuming that the ways things are in nature is intelligent, and we're learning from nature.
Yeah. Is that a reply that ID is doing research?
Yeah. Well, you could call that kind of research intelligent. Whether or not the research is doing it or operating on the assumption of intelligent design, you could argue that there is an implicit assumption of intelligence in nature there.
I could see someone making that argument. I think a stronger case could be made for them actually using the design inference itself, right? Because, like it or not, we do use design inferences in science. The entire SETI program, the Search for Extraterrestrial Life, is based on that. So as soon as you allow the fact that design is something that we can apprehend against randomness or natural processes like Darwinian evolution, as soon as you allow that, you allow for the possibility that ID theory is a scientific field, regardless of whether or not their practitioners are actually practicing.
There's a question related to that. I'm looking for it. There it is. Everyone needs a smile is asking, is there a scientifically rigorous definition of design that doesn't rely on intuition?
That doesn't rely on intuition, whether or not something is designed. Is there a scientific, I'm trying to wrestle with what exactly is there a scientifically way of testing? Because definitions are not scientific. They serve science, but definitions are not scientific. So I'm thinking maybe this questioner is asking whether or not there's like a criteria for that.
Like
is
the
that
William Paley's watch argument, people will say, oh, well, watches we know are designed because, that we know that the particular alloys found on the watch are never found in nature. They're found man-made, so the watch is man-made. However, we find bodies and we find organisms in nature, therefore we don't infer design when we see those. So that's the counter. So the point is, how do you define design in such a way that you can then just determine whether or not biology is designed and so on?
Yeah, and I mean, again, I'll appeal to William Dembski. You can debate this criteria or not, but they do at least offer one. When he arrives at something like 1 in 10 to the 500th power, if something has less than an odds of that, then the design inference goes through. And he arrives at that based on Planck length, Planck time, the movement of molecules, and basically in order to rule out natural processes, that some additional element has to be added in. And so that's his filter through which you can get through. So as long as design is a viable option and you can provide a filter to filter out other explanations, that would be a case.
What is it? Stephen Meyer, he makes an argument for intelligent design where he says it's an inference to the best hypothesis, and he argues that he's using the same type of argument that is used for evolution. So he's both of them, we can call them historical sciences. So there's not one scientific method. There's many different scientific methods, and different ones are used in different contexts. So for a historical science, you use inference to the best hypothesis. Like you find a layer of ash and a layer of sediment, and you assume, well, the only times we've seen ash like this before, and it was caused by volcanoes. We never see ash like this caused by anything else. Therefore, this ash found here was caused by a volcano. It's that kind of thing. So Darwin argued we find variations within existing organisms due to evolutionary forces happening. We can observe it happening, Darwin's fishes and so on. Therefore, when we see differences in organisms, we can infer that it happened by this cause. And then, there's debate that happens over whether, it's an extrapolation from the micro to the macro and so on, whether, small incremental stages can be extrapolated to explain for large scale changes. That's a separate debate. I'm just adding that as a caveat. So Stephen Meyer argues that he's using the same logic that we see. His main argument is from information and DNA. So the only thing we ever see creating new information is intelligent minds. We never see, so in evolution, when they see mutations, you can see like a duplication of a gene set, but duplicating something isn't creating new information. And, a random swapping out of another thing where, Michael Behe showed that usually what's happening is actually devolution, where you're destroying genes. And of course, that's another thing that can be debated. But I'm just talking about the argument and showing how it's parallel. Whether the science would obviously be a separate debate. And to have that debate, I'd want to get experts on.
Yeah. So not commenting on Meyer's thing.
We're not discussing that. I'm just pointing out what the argument
so we don't get into
I know people in the comments would go nuts.
But I will say, like, even with the criteria, I like that Dembski provided that, because for the quantitatively obsessed, which a lot of scientists are, that's great. But honestly, when it comes to design inferences within other fields, SETI, criminal investigations, archaeology, that's never employed. It's pretty obvious. And people like to complain, well, there could always be another natural process to explain, something we don't know about, some promissory note, again, that for a natural process to explain something, that you could employ that always, right? There could be some unknown brick making natural process which could account for why this building is in this location, but no one in their right mind considers that. So it's a correct thing, right? So the question always gets down to, do the natural processes already offered provide an explanation that can account for that? And there's a few more that go into that, but that's really the main question that it comes down to. So that's why I end up saying, ID theory is scientific. It's just not the best science. It's just not where I think the evidence leads.
Yeah, so Stephen Meyer argues, just like when we find a layer of ash, we assume a volcano. When we find information, we can assume a mind because we see minds creating information. Of course, people argue, well, you don't know that there's a supernatural mind capable of creating, the universe and life and so on. It's like, well, first of all, you don't know that there's not, and second of all, Stephen Meyer gives a rejoinder to that type of argument, which is basically archaeological. Let's say people find scratchings on caves, and we assume, okay, well, these kind of scratchings are only ever produced by humans. That's the only cause we know capable of producing these. And someone could just say, well, you have no reason to think humans were here. We don't know anything about humans having lived at this time, this long ago. And it's like, okay, well, you don't know that humans weren't here, first of all. And second of all, we know humans were here because humans must have done this. Nothing else could have done it. It's like, well, that's just an argument from ignorance. It's like, okay, then archaeology isn't a science if that's the kind of logic you're going to use. And if it's a valid argument against intelligent design, then it's a valid argument against archaeology.
Yeah, that's the thing. The comparison to SETI and archaeology, it really, because quite often archaeologists do have to posit unknown civilizations, or people, or unknown cities, or these sorts of things all the time, and on quite minimal amount of evidence. So we use the design inference to explain data quite a bit, and people will say, well, you're introducing something new into the system. Archaeologists do that all the time. That's what the data points to. SETI would do that. They would introduce aliens into the system if we got a hello humans beamed down to the Orobico's telescope.
Yeah.
Let's close down. Never mind. So some telescope got beamed down. Hello humans. That would immediately.
But if it's a,
that would immediately.
But not if it's a crop circle. If it's
a
crop circle, we'll just ignore it. Just write it off.
Oh my gosh. let's not even go there.
I'm joking. I might just work through a few of these questions because otherwise they'll get lost in the chat. So everyone needs a smile is asking another question. More questions for Seth. Is there a piece or group of evidence that is explained by intelligent design and not by evolution/abiogenesis?
Is there? No, I don't think so. Well, I don't think there's one. I mean, this is probably not a question for me, honestly.
Yeah, I mean, it's kind of off topic. I'm just working through the questions.
The question is, I mean, I think that here's the thing. I think probably if we really delved into it, there would probably be a few things that are difficult for the current paradigm to explain. Fair enough. I'm much more a fan of the extended evolutionary synthesis, which basically says Darwinism is one of many things that accounts for evolution right now. I was reading a thing recently where they found out horizontal gene transfer, where organisms giving some of their genes over to organisms. We used to think that was something for simple cell. Now they're finding it in fish. So like the mechanisms for evolution are wide and they're growing. So again, this is by the sheer trajectory of science. If there were something that an ID theorist would show to me and say, this is, the best explanation is design, I would probably say, yeah, probably that is for now. But I have, because evolutionary theory is in such a transitional phase right now, I don't know what it's going to come out as. And right now, the vast majority of the data is explained by that. And things that we didn't think would be, such as the eye, such as the bacterial flagellum, are being explained by that in a much better way. And so that gives me a sort of confidence. Is that a knockdown explanation against ID? No, I don't think it is. But I think it is the most rational explanation given the evidence.
All right, is there a piece of evidence that could be discovered that would falsify or simply diminish confidence in intelligent design? Well, one thing I think would do that is if they found successive photos, you take a photo of somebody every year and you look at them side by side and it's undeniable that it's the same person all the way along. But if you take one photo here and one photo when they're 30 and one photo when they're 80, you'll have no idea if it's the same person in every photo unless you knew that person for their whole life. So if they find fossils where we can see that kind of thing, where it goes from one organism to the next in a way that's undeniable that it's a progression through genetic evolution, I would say that would disprove intelligent design. Yeah, I would. The only thing I would add to that is I think there's a distinction that needs to be made, and I don't think critics of ID are careful in this, which is ID as a philosophy and ID as a science. Is there something I think that would falsify or undermine confidence or diminish confidence in ID? I think the example Arjuna gave, that would be great. Fossil records horribly incomplete, unfortunately, but that would be a great example of what would do it. The philosophy of intelligent design, that's more difficult. That's what a lot of critics of ID series say. Well, it's unfalsifiable. God could always have it could explain anything. Well, it could, but they're positing it as a science. They're not positing it as a philosophy. And I think that's a distinction we need to keep in mind there, because that latter one, you could always maintain, no matter what happens, that God created it. Well, I don't think abiogenesis is ever going to make any progress. So we'll always have that as a place where we can stick intelligent design. And then fine-tuning arguments, I also think, are substantial. Fine-tuning arguments, yeah. So, but they're purely philosophical in a sense. Yeah. Well, I mean, they arise from science, I suppose. Yeah, but they're really the big debate is a philosophical one, not a scientific one.
Right.
People on both sides of the debate agree on the science. The other point I could make is this one's from Gunter Beckley, that he talks about a sampling of the fossil record, and he gives an analogy that if you're at the beach and you're walking and you collect seashells, and every day you go for a walk, when you first go, you're finding new seashells every day, and after a couple of years, it's been, might have been a year since you ever discovered a kind of seashell or anything else on the beach which you've never seen before. So once you get to a point where you're not making new discoveries, you can kind of assume that the seashells you have discovered are an accurate representation of what's there on the beach, even though you haven't picked up everything on the beach or everything that's ever going to wash ashore. You've been doing it long enough that you've stopped getting new things coming in, and you can kind of assume at that point. Whereas if you're regularly getting new things coming in you haven't discovered, you can assume that your sample size is not large enough. You haven't sampled a big enough amount of the stuff out there in order to have a good picture of what's out there. So similarly with the fossil record, for what long time they were making new discoveries, new species, new things that they might claim are transition species. And after a while, they're no longer making those new discoveries. So at what point can we assume, okay, it's not, the artifact hypothesis, which is that the large changes that show up in the fossil record of just jumping from this organism to the next on the theory of evolution, you could explain those away using the artifact hypothesis, which is that we've just discovered this artifact and this artifact. There's a bunch in between, but we just haven't discovered them. But once you've sampled enough that you're no longer making new discoveries, there comes a point where you can rule out the artifact hypothesis and just say, okay, our sample size is big enough and the evidence is just not there for transitions.
Yeah, but that's extremly difficult because when it comes to the fossil record, because you have to realize that first off, a species has to be fossilized differently. So for the need or the requirements to get something fossilized, it's very specific. It's very specific, and certain organisms, based on their environment, their habits, and stuff like that, make it far less likely that they will be fossilized. Some organisms dissolve quicker. Some organisms with bigger bones, they might fossilize more easily whenever they might get buried easier. Or, I'm making this up as I go along, but the whole point is that fossilization is a very inconsistent process. The records that we have is very inconsistent. We're at the mercy of the geography and the geology of the Earth. We only have access to X number of sites where Cretaceous rock is there. So we only know, and even theoretically could know, organisms that existed in those areas. There's entire parts, let's say we're looking for land animals. There's entire portions of the Earth which are covered in water right now that used to be land, there's going to be whole species we do not know about. So, I mean, it's just the nature of the fossil record that it's going to be. I think in the last show we talked about this. I don't think the fossil record will, at like any single finds, and this was a big flaw I had with Aaron Raw, is any single find in a fossil record, it's difficult to say that that's good evidence. What's real, like because the only real evidence you can really pull from the fossil record is more of the overall trajectory. If you look at it holistically and in sort of a big picture, but that doesn't sell books. That doesn't get YouTube views. You want that one missing link, right? And that's I think that's why I don't say the fossil record grand total is the best evidence of evolutionary theory.
Perhaps it's the best evidence against it.
I wouldn't say that. I would say it's wholly consistent.
Yeah.
And yeah, okay. But again, we're getting into that.
I had Gunter Beckley on for debate discussion with Gutsick Gibbon, so that's quite interesting. Went for 3.5 hours, which is my longest stream yet. But I think I can get him on to do another one with someone who will perhaps challenge him a lot more heavily, because Erica was very friendly and very interested in learning what he had to say. So the pro-evolutionists might be disappointed, but I loved that discussion. With regard to your point about the fossil record and some organisms being poorly preserved, to support that hypothesis, we would want to see that in the areas, like what are the creatures called that live around the shore level, like sort of where the water comes up and goes, because that's where you get the most preservation of fossils in those conditions because of the silt and salt and whatever else. And those areas, the organisms that live there, we would expect to have the highest degree of transition fossils, and we don't find that.
Possibly, but it depends on the model of evolution you're using. right? I do think there are examples around that area that we do find transition. Those sorts of transition. There's other factors more than just biogeography. There's the fact that, for instance, birds are extremely difficult to find. Well, why is that? It's because their bones are hollow. They degrade quickly. And yet, we have great examples of birds with quite a few reptilian features. In fact, an overabundance, more than we should have. I think those are mysteries. Those are real interesting. But at the same time, would I count that as sort of broadly evidence in favor of evolutionary theory? Yeah, I think it's something that would predict, that the theory would predict, whereas ID theory might predict, but not necessarily would predict. You know, being consistent with the theory is different from predicting it. This is something that would be assumed,
right,
given the truth of the theory. So there are weird things like that. But for instance, we have an overabundance of whale bones as well. Whales don't live around the shore typically, and yet they're quite often used. So, and I mentioned the model of evolution, right, as well. The last thing is punctuated equilibrium. Assuming punctuated equilibrium, which most biologists do now, we would not expect very many transitional forms.
We discussed that one.
And Niles Eldredge.
We discussed that one
Sorry.
a little bit on our video responding to Aaron Ra, so people can watch that if they want, rather than us having that discussion again.
I'm talking forever again. Let's
to
Carl Sagan.
Your points were a response to what I said, so it's fair enough. But I'm not going to then open up a new discussion. That's all I'm saying.
That makes sense.
This one's from Genetically Modified Skeptic.
If there's no conceivable way to put an idea to the test, it isn't one from which we can build any meaningful explanations. An unfalsifiable proposition is one which can only have explanatory power if flatly assumed true, and of course, we're not in the business of making unnecessary assumptions in search of truth. For those still unsure of this tool, let's consider a world where, instead of accepting ideas when they're evidenced to be true, we accept ideas when they can't be proven false. Well, I assert that there's someone standing behind you right now. You say you've turned around and you can't see them? Well, that's just because the person is fast and they can stay out of your field of vision no matter how you move. Your back is against a wall? Oh, well, they can just move through solid objects, no problem. No one else says they can see them? Well, that's just because they're being paid off by big standing behind you guy. No matter how you object to my claim, in a world where we accept claims because they can't be falsified, you've got to accept it no matter how absurd it gets. I could claim that the universe rests on the back of a turtle, or that you popped into existence 10 seconds ago with all of your memories, and you'd have to accept it. Any and every idea that couldn't be proven wrong would have to be accepted in such a world, and that would lead to complete absurdity. Ensuring that our hypotheses are falsifiable keeps us grounded in the world where evidence is required for an idea to be considered true. Sagan's complete baloney detection kit, as detailed in The Demon Haunted World, goes on to cover multiple...
Well, maybe I didn't cut it off at the right spot.
Yeah. So there's I threw that out there because there's a very clear case of somebody taking the very popular scientific line of falsificationism, which I won't repeat points much, but just to say one thing, there are certain things. So I can't prove that I popped into existence 10 seconds ago with all my memories implanted within me, the Omphalos hypothesis. But at the same time, black holes, theoretically, are unfalsifiable. If I were to say there is a golden sphere 1 kilometer in diameter somewhere in the universe, that's a scientific hypothesis. But I mean, it clearly is something we could test. But that's not falsifiable, because given a finite number of observers, just like the black hole, it could always be, just like his person behind him, it could always be that gold sphere is hiding someplace that we're not. So it's an unfalsifiable hypothesis, and yet we clearly view it as scientific. So using this as a demarcation line, it's not good. And let me give you, and he did waver. Very beginning, he says, if we switch from saying things that we can have evidence for to things that we can't disprove, he mixes up, in that one statement, he mixes up verificationism and falsificationism. But even to show you, let's say we can combine these together. Aaron Ra did that in one of his videos. He said, well, they should be both verifiable and falsifiable simultaneously. Well, let me give you one example. It's one I've already used. Every metal dissolves in some kind of acid. Is that verifiable? No. There could always be another acid there could always be another sort of metal that doesn't dissolve. We just haven't found that metal. That's not verifiable. Is it falsifiable? Well, no, the very same reason. Because if we found a metal that doesn't dissolve in any of the acids we know, there could always be another acid that we haven't discovered
Well, you could
yet.
just say it's not a metal
clear,
because you've defined a metal as something which dissolves in acid.
Yeah, and even if we did have a definition of a metal, there always could be another kind of acid that we just haven't tried out yet. So it's neither verifiable nor falsifiable, yet very clearly, if I were the statement, every metal dissolves in some kind of acid, is very clearly a scientific statement. No one would call that pseudoscience on the level of astrology or alchemy.
Well, perhaps your objection there hinges on rejecting fallibilism.
Fallibilism in what sense?
So, we can have confidence in that statement and therefore call it scientific, but sure, we can't have absolute confidence. There's always a chance that it's wrong.
Right. And it's not necessarily that. It's this idea that statement is neither verifiable nor falsifiable. And by falsification, we need to be able to say we've tested every instance and shown this, right? Because the most you could say is of all the metals we have tested, they can dissolve in acid. So that would be the most you could say that.
So how would you define science, or have you not got a definition?
This is it. I take a very Feyerabend take, which for anyone who knows, that's fairly radical, but it's also one that's most consistent. Paul Feyerabend, he wrote a book called Against Method. And it was this idea that when it comes to science, we don't have a good definition, and we actually need to encourage people to do real bold things. Like go out and take risks, find new methods, think of new things that just don't fit within the sociological driven ideas that often drive science. That's I think Thomas Kuhn has shown that exhaustively, and just forget about that there being a demarcation line. It's merely an empirical attempt to discover the world. And he points to Galileo. Galileo is a hero for Feyerabend, basically, because Galileo did a lot of things that by today's standards would not be considered scientific to try and support heliocentrism. And yet he's elevated as a hero of science. And he says, right, there is no clear definition of science. We should stop trying to demarcate them and just allow people to do these sorts of empirical research without stigmatizing fields that we don't like. Now, that doesn't mean that there aren't better and worse ideas. I think there are reasons to trust certain sciences, the things we teach in school and stuff like that. I'm not advocating for alchemy to be reintroduced into high school curriculum at all. But I am saying we need to stop trying to stigmatize these sorts of fields as pseudoscientific and just recognize them as bad science, not pseudoscience. Does that make sense?
Yeah. So that would be a kind of like, where the rubber hits the road kind of thing, like sort of going out, exploring the world and seeing what gets results and what works and what doesn't, as opposed to having some like cookie cutter definition, which is going to fail.
Yeah. I'm actually really big fans of the scientists who have sort of bucked against trends and really sort of pushed the envelope when it comes to certain assumptions, even if I don't agree with that, because I think that's how paradigm shifts happen. That's how we're going to discover the world. The biggest problem within science right now is that the reigning paradigms of materialism, naturalism, mechanism, and those sorts of things not only have been subjected to some serious critiques, but I feel like they've also held back viable hypotheses, which should, and obviously need to be taken into account and be treated as fully scientific.
So where would phrenology fit with all that? That's widely regarded as pseudoscience, but perhaps on your definition at the time when it hadn't been debunked, they were doing science. If you were to do it today, it would be pseudoscience because we already know that it's false.
Yeah, exactly. I would consider that bad science. I wouldn't consider it pseudoscience because who knows? Maybe there is a connection. I mean, 1,000 years ago, how were they to know? 1,000 years ago, how were they to know whether or not you could turn a metal into gold?
Right.
And yet, yeah.
So they were.
And so it's only because of empirical discoveries that we know that. But that doesn't make those not scientific. That makes that just bad science. It was science that turned out not to be right.
Right. We've got a couple more clips. This one's the Matt Dillahunty and Jordan Peterson one. Oh, I've got the sound off. Hang on.
Never construe it as a scientific issue because science can't confirm the supernatural. I mean, we are blocked until somebody demonstrates a mechanism by which we can explore and confirm the existence of the supernatural and then confirm that it actually can impact the natural world. We're stuck, which is why science relies on methodological naturalism.
Jordan's implication that we can...
That was enough, eh?
Yeah. Since so this is his criticism of Jordan Peterson, and I think Jordan Peterson was taking the stance that psychedelic experiences induced by drugs might have a supernatural dimension to them. That seems to be I haven't watched the whole debate, but that seems to be what the topic was that Dillahunty was replying to, which is oddly a stance that's growing in support. I'm meeting more and more people within academia who are sort of taking this idea seriously. I have no opinion on this, but it's an interesting idea at the very least. So, but I think I like this clip, and I pointed it out to you because I think this is one of the demarcating lines that we haven't touched on yet, which is methodological naturalism. What makes something scientific is it assumes methodological naturalism. Only natural things cause natural things. To suppose that a supernatural agent, this is why it's dismissed ID theory and creationism, to suppose a supernatural agent is to impose, it's a less simple explanation. It's to impose a new framework into science when science should only suppose that material things cause material things. That's the sort of broad overview of methodological naturalism. Stick to nature and just assume that only natural things cause natural things. It's not to say it's true, but that's going to be the reigning assumption. Now, the reason why a lot of philosophers of science don't like this is because, for one, what are the reasons why we should assume this? Well, some of the things I've heard is that, well, the supernatural is not testable and repeatable. Well, how do you know that? Have you tried it? It's sort of just an assumption. Let's say it doesn't seem prima facie implausible to say, let's just say, as a thought experiment, ghosts exist and they start talking to us if we shine a light at a certain frequency. Now, that seems to be that's a supernatural explanation that would be testable and repeatable. Just prima facie, that seems plausible. So there's no prima facie reason to assume that supernatural explanations are not empirically testable. Well, another possible explanation for this criteria is that it's less simple. Why would you insert the supernatural when natural explanations are more simple? And as anyone who knows about Occam's razor knows, simplicity, even if we have some good definition of it, like I said, I don't think we do, simplicity is only invoked when you have two explanations that equally explain the data. Do not multiply hypotheses beyond necessity. But when they're needed, that's perfectly legitimate. So simplicity can't be the reason for it. So now methodological naturalism is sounding more and more like dogma, just the reasons why people assume it. And the second reason I point out why philosophers of science don't accept it is quite often the best definition they can give is question begging, which is a thing is scientific if it's natural. Well, what is a natural thing? It's a thing that's scientific. And so these two terms are sort of defined by one another. And it's a way of maintaining status quo and keeping out entities that sort of don't fit within established paradigms. But that's a philosophical case. And that should be alien to how we actually practice science. Science should be based on a search for the truth, based on a certain methodology, which arrives at the truth, not based on we already know the truth. We already know the philosophical truth. We're going to rule out any explanations that might contradict that. That's obviously an unscientific attitude. And so for those two reasons, that sort of explanation that Dillahunty is offering is just completely rejected.
Well, another problem with it is it limits science. So, I mean, if the natural world is all that exists, then the limitation is not real, it's just hypothetical. But if there is something beyond
Mhm.
nature that exists, then the limitation means that science is no longer something that tells us what's true and what's not true. It's something that tells us what's true and not true within a very limited domain. And of course, for the
Right.
naturalists, they're not gonna have a problem with that because they already believe that's what exists. But they haven't demonstrated that in any way. They've just simply assumed it.
Right. And that's the very sort of unscientific attitude that's being smuggled in. And so you need some other justification for it, right? Which is either, well, it's more simple. That's obviously more simple, which I've shown that's not the case. We don't have a good definition of what simplicity is, and you can only invoke that whenever all things are equal. And number two, it's not testable or repeatable, which at least prima facie, there is no reason for assuming that supernatural explanations are not testable and repeatable. There's quite a few people who have claimed to be able to do miracles or do sort of these supernatural things. That at least on face value, you could set up these sorts of tests, and they have been done, where you can rule out whether or not there's a natural explanation, or you can at least provide at least initial evidence for the claim to back up their claims. Now, there you could always say, well, there's something that we haven't put into the equation. So, for instance, say somebody accurately reads your mind every single time and says, I'm a mind reader, right? Well, there could be something they've done. They could have implanted some device in your head. And you can get more and more ad hoc to try to explain it in order to preserve that. But that sort of ad hoc introduction of things is ruled out in every other science. There could always be other explanations in science to account for the data, but you can't just multiply hypotheses in order to avoid a certain conclusion. So again, that's an unscientific attitude that's being portrayed in order to preserve methodological naturalism. Does that make sense?
Yeah. I mean, another question is, how do you define natural versus supernatural?
Yeah. I actually don't think there is a good delineation there.
I mean, I've had some atheists tell me that if God existed, God would be natural, because nature is just everything that exists.
You know, what is interesting is if you were to ask, say, early Christians, is God natural? So the word supernatural was really, so a guy named Peter Harrison and another French scholar, Henri de Lubac, have really pointed out that the word supernatural is a pretty new word, last 500 years. So if you were to ask early Christians, and I can only speak for my tradition, is God natural? They would have said yes. God has a nature. Of course he's natural. We know God's nature. God is naturally good. God is naturally all powerful. So yeah, that's what the word natural meant to them.
Oh yeah. This modern use of the word natural and supernatural is it's really odd, because for the theist, they will claim that there's plenty of things that are natural, that they're part of nature, that aren't physical.
Mm-hmm.
Of course, some naturalists might agree with that, but the theist means things that aren't physical in a different sense from what I don't know. There's some versions of naturalism which it's questionable how much they keep their distance from theism.
Yeah, I think the word nature, it's such a slippery term. And I use that as the Christian example, as an extreme example, to show you how the word has evolved. Like over 2,000 years, the idea of calling God natural nearly seems, if you told a modern day Christian that, they'd be like, oh, blasphemy, God is supernatural. That distinction between nature and supernature is a very modern division that didn't exist.
Spartan Theology is asking, would the Force in Star Wars be natural or supernatural? I mean,
who knows?
If it's a force that exists, then you could call it natural. It really depends what you mean by these words. The Force in Star Wars appears to have been borrowed from this idea of dharma, which you get from the Vedas. There's a statement in the Vedas, dharma himsito himsita rakshita rakshito, which is that if dharma is harmed, it harms, and if it's protected, it protects. So, in other words, if you keep things right with you and the moral laws of the universe, in other words, with God, then you'll be protected. And if you violate the moral laws of the universe, you're gonna have nature come down on you like a ton of bricks.
I gotta say thank you to George Lucas for problematizing those categories. Honestly, Spartan. By the way, hey, Spartan Theology. Good to see you. But George Lucas, yeah, I think that's a perfect illustration. I hadn't thought of that until now. Is the force sort of transcends the boundary between natural and supernatural.
Everyone needs the smiles. We had one last question about whether we think that there's aliens that exist somewhere out there. That the Vedic literature talks about living entities being found everywhere. There's even described that the sun is occupied by inhabitants who have bodies made out of fire. So, and then of course you could look at the recent UFO evidence, which has been disclosed by the US government, and make a compelling case for it there. But of course, skeptics and philosophers and scientists don't care about UFOs, even if the US government's releasing it, which I find kind of amusing. It's like, oh, are we ever going to see evidence for UFO, for aliens? And it's like, it's on the daily news, and like nobody in the discourse of philosophy of religion blinks.
Yeah, I think actually, I'm really glad someone actually brought this up. It's really not off topic, because ufology 50 years ago was about as fringe as science, pseudoscience as you can get. Look at the last 4 years since the 2017 New York Times article. Ufology has gained, I mean, Michio Kaku has said the burden of proof is now on those who say there aren't alien visitations to Earth. Now, whether or not you think Michio Kaku's right, I think you can question that. It definitely shows a sea change that's happening. Who knows? 50 years from now, ufology could be just another field of study. I'm not saying they'll discover aliens or not, but that shows you, I think it's a perfect example of how a field can move from pseudoscience to science purely based on, on non-scientific factors, really. It's not as if the evidence is exponentially better. It's not as if the videos the government released are better than videos that we've had before. I'll be honest, they're really not that good.
The only difference is it's been given a rubber stamp, and now you're allowed to talk about it without being seen as a fringe lunatic.
No, exactly. Yeah, it's given the government stamp of approval, right? But we had, before that, Chile had released UFO video. The Chilean military had. Nobody took that seriously. It's the U.S. I hate to say it's ethnocentrism, but it's the U.S. video that that did that. So it just shows you like what's scientific and what's not scientific. I would love to say there's some good criteria. It's not. It's
the definition.
Sociological.
Here's the definition of science versus pseudoscience. Science is that which the ruling authorities tell you is okay to believe, and that which you're told to disbelieve is pseudoscience.
Yeah, I mean, I would actually. So there's so anyone who knows Lysenko. Lysenkoism, I think that's how it's said. Lysenko, he was the head biologist in Soviet Russia after World War II. And he didn't like Darwinian evolution and had his own brand of evolutionary theory, had a whole scientific program. Top scientists in one of the world's two superpowers all virtually were forced to operate under the assumptions of this scientist they use in quotes. But today, since the downfall of the Soviet Union, the fall of that whole paradigm is considered pseudoscientific. So there's a case of something moving from science to pseudoscience based on sociological factors.
Right.
We don't even have to get into the science of it. No scientist today actually even looks at the science they did. I haven't. We just know that it's pseudoscientific because we're told it. It's from the Soviet Union. They were ideologically motivated. Blah 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 blah.
Well, I mean,
so it goes both ways.
How do we know there's not ideological motivations in science today?
Oh, there is. I think that's kind of my point. I mean, I think that's undoubtedly the case. What gets funding? What scientific projects get funding? It's the ones that we care about. Now, I'm not saying that's wrong, but science is driven by personal interests.
Yeah. Well,
that's not a bad thing necessarily.
And political interests and career interests of the scientists and financial interests of corporations.
Yeah, absolutely. I mean, look at how many scientists signed off on cigarettes don't cause cancer.
Yeah.
I mean, that's probably a real bad example of it, but it shows you that science can be corrupted, and it's a good warning sign.
I mean, there's a good question, which is why hasn't science made much progress in recent decades? Like, the turn of the century, up until, I don't know when, definitely the 60s, 70s, a lot of progress was made. But since then, it's been a lot slower. And, it could just be that we've discovered all the things that are easy to discover and it gets a lot harder. That could be true. But one explanation I heard for it is that during, I think, World War II it was, scientists needed to be developing weapons, and you needed teams of scientists to collaborate. And it was no longer, for that kind of thing, it's not useful to have some kind of Max Planck, going down all these weird philosophical rabbit holes. Whereas, but before that, you had these polymaths that were as much philosophers as they were scientists, and they did many subjects, and they went down really obscure lines of reasoning, and they made all these breakthroughs. Some of them actually said that they made breakthroughs as a result of inspiration they took from reading Bhagavad Gita or other things from the Vedas, for example. Whereas these days, it's very, you're not allowed to think about their metaphysical stuff. It's all like hard physical stuff and nose to the grindstone kind of thing. And the other reason could be, groupthink, like, there's all these, that's pseudoscience. You're not supposed to do that. So because people aren't exploring, following their intuitions, they're following groupthink and what they're told to think, and, worried about their reputation and how to position themselves so they'll get ahead. They're not making the breakthroughs that they might if they just followed their own intuitions and inspiration.
Yeah, Firebind was actually a real, points this out quite a bit. There's been a whole, I'm actually opposed to some of the things that have come out from him. There's this whole thing called sociology of science, which tries to sort of undermine that science makes any sort of progress. That's the sort of extreme angle on that. I'm quite opposed to that. I take the more Kuhnian idea that scientific progress kind of goes in leaps and bounds rather than slow at a time. And I think exactly what you're pointing out is there was a paradigm shift around the first part of the 20th century, which we moved away from Newtonian mechanics, because we forget that just before then, people had thought physics was coming to an end as well. But then there was this massive paradigm shift in what we thought about the universe, thanks to Niels Bohr, Albert Einstein. And there was a lot of fruitful research for 50 years after that. In this, anywhere between like 1900, 1950, 1960, that was a huge period. And now we're sort of in that stalling period again. And so perhaps what we need is another paradigm shift. Perhaps we need those bold scientists to go forth.
So I think we're probably gonna have to wrap it up soon. But at this point, it's worth mentioning that methodological naturalism, it doesn't make metaphysical assumptions. I'm just going to paraphrase, but you can read the point. What it does is it just takes it as a sort of starting point, and then goes out and tries to figure out what's true based on that. So you can't do science if you're going to assume that anything could happen at any time because of supernatural beliefs. You kind of have to assume a mechanistic structure that things are going to be predictable and so on in order to go out and do experiments. But then you see what the results are, and you work out later on whether your assumptions are true. Whereas philosophical naturalism makes the metaphysical assumption, and that would just be begging the question.
Well, a few points there. There's one is the unfortunate thing that it's just a method, right, with no sort of philosophical baggage carried with it. Well, yes, it is. It absolutely has to be, because the very idea of why we're assuming this method, which has naturalism, which is a philosophical stance in it, baked into it, there has to be some justification for that. So even if you say, well, we're not assuming naturalism, and I even pointed that out when I said that, it's not ontological or metaphysical naturalism, it's different, but you still have to justify why you're assuming that for the sake. And you said this person, you were paraphrasing someone else, right?
I was paraphrasing the comment, yeah, this one.
Yeah. Which is mechanism. Well, why do we assume the universe is mechanistic, right?
This one.
So why do we assume the universe is mechanistic, right? So so if you actually look at the history of Marin Messen, Gallendi, Descartes, Bacon, why did they assume the universe operated like a machine? Because of theistic assumptions, and they were trying to resist emerging philosophies of the day, which had a bit more of an occult element to them, like Neoplatonism and stuff. So again, this was a theological motivation, and to a certain point, philosophical, but mostly theological motivation for them of establishing science upon this idea of mechanism. Would science work without the assumption of mechanism, that there could be novel things? Yeah, it could be. It would be a little bit different. Things like, again, I've undermined the idea that things have to be testable and repeatable in order to be truly scientific. Otherwise, we would have to throw out all meteorology. So obviously, we can have novel things. And the second thing is I've also pointed out that perhaps the supernatural could be testable and repeatable. So again, I think the objections you're raising, they're very common, but they just don't cut it.
But like,
because they just
If you're going to make a motor
Go ahead.
vehicle, you need to assume that petrol is going to combust at the same pressure today, tomorrow, and the next day, so that you can tune the engine and, you know, calibrate it and all that sort of stuff.
Right, and I would say that was one field that you probably would want to have testability, repeatability. But as we know, engines fail all the time for unpredictable reasons. There's certain other variables that can get into this effect. We can study those variables as well. We can study the unpredictability just as much as we can study the predictability. We just enter into a different mode of science, a very Baconian empirical science, where we go when we watch, we look, and then we infer. That's a different mode of science, but it's perfectly legitimate form of science.
Right. But when you're designing a motor vehicle, you need to assume predictability.
Yeah, I would assume, yeah.
So that would be a valid application of methodological naturalism.
It would be a valid application of. It would be a valid application of mechanism. Yeah,
right.
I wouldn't say methodological naturalism. I don't think.
Right.
Yeah, go ahead. Yeah, because you're just assuming the machine mechanism is predictable. You don't have to go any further and say there's no supernatural causes writ large or anything like that.
So we've got a couple of Aaron Ra clips and then one from Michael Shermer. I don't know. I mean, we could just wrap it up. We've been going for over 2 hours now. I don't know what you want to do.
It's up to you, man.
Let's keep going then. We can probably wrap it up in 15 minutes if we power through them.
Okay.
So I like to think of science as the methods we use to differentiate between reality and imagination. Do you think that's a fair characterization of what science is?
Well, science is a tool to improve understanding. I mean, so I guess that would be a fair assessment. There are different ways of phrasing, I think, the same thing.
I mean, that was just a very generic point.
Yeah, generic point that I wanted to include Aaron Ra and T-Jump, and I tried desperately to find out how they did it. That's as good as I could get, and I think that just reveals a way of. I mean,
we got 2 more.
Theology
clips.
Would fit into that. Yeah,
we've done T-Jump, and we got 2 more clips from Aaron Ra. Yeah, I mean, I would define science as reliable means of acquiring knowledge and achieving results. In which case, you could have a spiritual science if there was a such thing as spiritual knowledge, if there was a way to get it. And if you could get spiritual results, like you chant Hare Krishna, your consciousness will become elevated. Elevating your consciousness means you'll no longer be prone to temptations of vices. Vices we can pretty much universally accept as bad. If you don't accept those things as bad, you're not going to be interested in Krishna consciousness anyway, so you wouldn't even care if it's true and just go and live as what's the word? Just go and live a degraded life by the lights of Krishna consciousness. You might think it's an elevated life.
And real quick, I apologize for subjecting everyone to this image for this long.
Let's play it now so they can stop looking.
Because here's the big problem. The problem with creationism, the worst failure of creationism is simply that it doesn't work. Not just that it can't compete and that it needs to be fleshed out a bit. It just doesn't work. So in creationism, we have a host of claims which can't be verified. We have no kind of science that we can use. There's no products. There's no experiments. It does not advance knowledge at all. And one of the challenges that I would offer to creationism is this. Can you name one time, one occasion in the history of science when assuming supernatural explanations has ever improved our understanding of anything?
The Big Bang. So, I mean, I take his point, but that is one of the worst things. He says it doesn't work, right? It's not just it just needs to be improved or that it's outcompeted, which is my point. I think it is outcompeted. But let's take a real simple thing. Assuming a supernatural creation, which again we're using supernatural, but let's just roll with it. Assuming a supernatural creation of the universe a finite amount of time ago. That's been in standard Christian theology as far back as I can trace it for 1800 years, since 200 BC, since 200 AD, excuse me. Since 200 AD, Christians have believed that the universe has a finite age to it. So I read this somewhere, and I wish I could remember it. In 1960, this is hilarious. In 1960, young Earth creationists had a better date for the Earth and for the world, had a better date for the universe than 80% of the physicists, top physicists in the world, who assumed it was eternally old. I just find that remarkable, but it's true because they had assumed this Christian doctrine Like young Earth creationists, they were wrong. It's billions of years old, but that's still infinitely closer than the scientists who assumed that the universe had adopted the Fred Hoyle's steady state theory,
Right.
and assumed the universe was infinite.
Right.
Was just infinite in age.
Yeah. So
Yeah.
I mean,
So they're infinitely closer. I just want to tell this real quick. Robert Jastrow is a great physicist. He wrote a book called God and the Astronomers. He's an agnostic, and at the end of the book, he says, "We scientists have climbed every hill, gotten to the final peak, and as we pull ourselves over, I'm paraphrasing, as we pull ourselves over, we're greeted by a band of theologians w'ho've been there the whole time."
Oh, I tried.
And again,
I tried to quote that
sorry.
yesterday, and I couldn't remember the quote. So, if anyone tuned that, now they
Yeah.
can hear the real quote attributed.
Yeah, it's Robert Jastrow, God and the Astronomers. Yeah, check it. It's how he ends the book. And so you could say, well, this isn't an advocacy of the Kalam cosmological argument. I think that's. But again, Aaron Ra asked, give us a supernatural explanation that would have predicted something better than a naturalistic one. That's one that did. Like uncontroversially, even if the Kalam cosmological argument doesn't work, that was a prediction being made by Christians long before scientists were, and it turned out to be far more correct.
I don't know how good you are at discussing the Big Bang, but somebody's claiming we don't assume anything supernatural about the Big Bang. The Big Bang is largely understood, and it's entirely natural. It's the events preceding the Big Bang, inflation, that we're fuzzy about.
So inflation is controversial. He's talking about Alan Guth's idea of inflation, which there's different models of inflation. So, and there's none that are sort of universally accepted. And inflation itself isn't universally accepted. It's just one of these ideas that is floating about with a possible confirmation coming within the next 50 years within physics. So that the thing is, so when he says that what we're fuzzy about with inflation, he's right. We don't know whether inflation happened, but at the same time, we don't. Saying that the Big Bang is entirely natural. Well, no. If you assume that it collapses into a singularity, that when you get past a certain size, the Planck length, that it continues on to collapse into a singularity, it can't be perfectly natural. And so I don't see any sort of defense of that. And again, my point is not to say that there is a supernatural explanation. I'm a bit fuzzy on whether or not that actually works. I'm not saying that. What I am saying is that is a prediction made by Christians, specifically Christians. You can talk about you'll probably know other religions better than I do. Well, but it was a prediction made by Christians that ended up being correct, whereas the predominant scientific interpretation of the time was not. So even by Aaron Ra's own criteria, creationists fly, they pass through as a scientific enterprise, and that's quite unfortunate for him, since that's his entire career is based on that.
Someone's saying we should assume it's natural until it's proven supernatural.
So so again, what do we mean by natural and supernatural? So I don't know how much of this show this person's seen, but we've problematized that category. And I've also talked about simplicity. What does it mean for something to be more simple? It's not well understood, because the assumption there is that the natural is more simple, or that it's more, that we know there's a natural, we don't know there's a supernatural, all that sort of jazz, which again gets into real problems of another demarcation problem. What is supernatural? Because I don't think we can describe the natural without the supernatural. So there's a lot of problems with that. And again, assuming the natural until the supernatural is proven, what are we talking about by proven? Are we talking about it's the best explanation? Are we talking about it's slightly better? Are we talking 99%? So, I mean, there's a lot I could say of that, but again, that's 6 words, so I don't know what more to say.
Right. Let's play another clip.
Science is biased, just like religion is. Well, actually, no. Scientists, being human, understand that every human has biases. And we understand that the worst science is that which is biased. And that's why we have a peer review process, and that's why we have evidence-based postulations, where you cannot say that anything is true. You can't even say that anything might be true. until you have evidence showing that at least the circumstances are favorable. You certainly can't say that anything is true unless you can show that it evidently is true. It doesn't matter how hard you believe it. If you say, I believe X, and you don't have evidence behind it, you've destroyed your own reputation as a scientist.
Where's the evidence for the inflation model? Because isn't the inflation the idea that the Big Bang expanded at a really fast pace and then suddenly slowed down to just the right speed so that we could have matter spread out into the right densities to form galaxies and stars and so on?
Yeah, it's posited as a way to explain observed data, but it itself, the mechanism and all these sorts of things, it's one of those ideas that's floating about. Sounds great. But it's waiting for empirical.
What's the mechanism? It sounds pretty ad hoc too, because from my understanding, the speed that it needs to go at, and then the sudden speed that it needs to stop, and then slow down to, are incredibly finely tuned.
Yeah, and again, there's so many different models. Like, good luck trying to keep up with that and not being a physicist. So, what I would say is, I do think his idea of science is highly idealized, and unfortunately, as you pointed out earlier, when it comes to conservatives and liberals, the ideal doesn't always meet reality. Have we talked about the replication crisis in science?
No, we haven't.
So the replication crisis, I have a buddy who does psychology at Oxford, teaches psychology at Oxford. I've discussed this with him recently, and he pointed out that within his field, around half of peer-reviewed papers are now coming under review and finding out that they can't be replicated. So psychology is sort of in a soul-searching period, I suppose, because at least half of the studies, many of them foundational to the field, turn out not to be correct, or at least can't be replicated. And then remember, a point of science is that it's repeatable, right? So, and this replication crisis has now extended into other fields. So the idea that science, it's self-correcting, it's all this sort of stuff. Well, that's not necessarily true, because in psychology, this went unnoticed for years. And there's cases of scientists that have actually made careers off publishing peer-reviewed research where they're just recycling the same data over and over, and they're fudging data. And some of these have gotten into Ivy League schools, have taught at Ivy League schools, and they've been caught with fraud of this sort. So peer review is not perfect, and bias gets into the way. And I think one of the worst effects is, I think we've also talked about this, is the file drawer effect, which is scientists need positive results. That's just the thing. They need positive results. And because of that, quite often you might have 10 experiments where only one shows what you're wanting it to show. Guess which one gets published? You're going to submit for publication.
The one with
you're going to submit the one that confirmed. Yeah. And you're going to leave behind the 9. And of course, when it does peer review, they don't actually repeat the experiment, at least not often. Very rarely do scientists have the time, and there's no credential. Like, you don't build your credit going through exhaustive effort of repeating some other scientist's experiment. Normally, they just check the statistics, check and make sure they checked all the boxes, and then they publish it. And that's how a lot of how peer review works. Unfortunately, it's just the scientists are busy and they all have their own projects. But it's a decent checks and balance system, but it's not perfect. And because of that, things like the file drawer effect, things like this replication crisis, which is spread out from psychology, these things are happening now. Because science is now discovering that it's not quite as unbiased, it's not quite as self-correcting as we had always assumed it would be.
Right. Shall we move on to the Michael Shermer clip?
Okay,
that's
the last
right.
one,
I was going to speed it up because let's see if I can do. It's going to be too long because I'll have to speed it up and also change the pitch, so that won't work. It's
my own, because I started encountering other people that disagreed with me. We never went to the moon people, conspiracy people, whatever. And I thought, okay, so how do we know if I don't know what's coming down the pike, say in 10 years from now, if I was going to teach my students how to think critically, what are the key points, like just basic questions they could ask. So it begins with one, how reliable is the source of the claim? Here's the claim. How reliable is it? What's the evidence for it? What's the quality of the evidence? Where does it come from? Who said that? Is this some, fake news alternative site thing, or is it, the Wall Street Journal or the New York Times? I mean, the source really matters. Has anyone tried to disprove the claim? This is super important because everybody thinks they're right. And every website has testimonials about this product or that idea. The question is not what do your supporters think, but what do the people who don't agree with you think? Because that's what I want to know. Has anyone run an experiment to try to disprove your theory? And so in science, this is as basic as it gets. Karl Popper called this the principle of falsification. That is, we can't ever prove a theory correct, but we can disprove it by having an experiment that shows it's wrong. Okay, so if you can't falsify it, what are you really doing? And my favorite story on this, by the way, let me just have a little sidetrack here from Karl. He's got this great little section in his book, Demon Haunted World. There's a dragon in my garage. Okay, I have a dragon in my garage. You want to see it? Come here, let me show you. So I pull up the garage door. I go, look, can you see the dragon? And you look in there, you go, well, no, I don't see anything. Sorry. This is an invisible dragon.
We kind of heard a similar point like that about the man standing behind you from Genetically Modified Skeptics.
Somebody has an agenda. So when you watch Fox News, you know that they have an agenda for sure. Or there's other sources on the left that have a liberal agenda, maybe NPR, who knows. But you see, it's good to know that, just in case. So when you hear the fact, you go, well, maybe, but I know this guy has an agenda. So, that's the kind of thing. Does the new idea being proposed account for the same amount of information that the old idea does and some of the new anomalies that the old idea can't explain? So people offer theories, so-called alternative theories of physics, for example. And they always send them to me going, hey, listen, I'm not good at math, but if you help me with the math, I'll share the Nobel Prize with you. Right. I don't do math and physics, so, you might take it to the local high school physics teacher before you announce that you've made the greatest discovery since Newton and Einstein. The problem with that is the current theories do pretty well at explaining most everything. Not everything, so there's always anomalies we can't explain, so maybe there's some new theory coming down the pike that might account for all the old theories' explanations and the new anomalies, the anomalies that the old theory can't explain. Maybe. But again, we got to be able to test it first. And so those are the kinds of things. Does the claimant play by the rules of science, the rules of the field that you're in, for example? Again, these alternative physics guys come to me. Don't come to me. I'm not a physicist. Did you at least ask the local high school physics teacher if this makes any sense? Because if you have no training, you don't know all the mistakes that people in the past have already made to get to where they are now. And if you're starting here without the background, you're going to make lots of mistakes. Okay. So these are the sorts of things.
That's about it.
Yeah, I think a lot of it would just be repeating what I've said so far. I mean, a lot of those are probably decent principles for everyday life, but when it comes to like falsificationism, the bias of the source and those sorts of things, it just becomes extremely problematic in modern day science. Modern day science is really in a soul searching period, I think, right now as well, with more people working on the demarcation problem, more people working on on the issues I've talked about, replication crisis. And it'll be interesting to see what the next 20 to 30 years, what people 20 to 30 years from now think of science. The paradigms that we used to work under are slowly but surely shattering. And I look forward to that.
Right. So maybe we'll wrap it up there. Any final points?
Final points. Demarcation problem. It's a real problem, and I think it reveals the distinction between science and pseudoscience is false. There is no such distinction. So if you're an aspiring scientist and you want to do something like this, if you're someone who's interested in this stuff, don't let that ascription be anything more than rhetoric to you. It's nothing. Go out, explore the world, come to your conclusions, base it on evidence, base it on how you think reality is. That's, again, I think we've talked about that as a necessary but not sufficient condition, and let that tie you down. What is the world? What is the reality actually like?
Sweet, cool. So thanks for coming on. I really enjoyed that discussion.
Yeah, me too. Appreciate it a lot.
And then to the audience, thanks for tuning in. Please like and comment to help us in the algorithm. If you enjoy this kind of thing, be sure to subscribe. We've got lots more content coming up. And I'll see you in the next one. Hare Krishna.
Take care, man.
I'll find the outro now. Hang on. What? Okay.